Hi class, and welcome to lesson 1.4 trig applications. Today we're going to be stepping back from the standard position and rotation angles and just go back to some familiar trig problems, possibly from grade 10 and 11. So just remember guys, we're going to use SOHCAHTOA because today we're going to be dealing with right triangles, and we might have a multi-step problem, i.e. we may need to use more than one triangle to help us solve this. So here's our steps. Number 1, read the question. Number 2, draw a diagram, and you may have to be one or more triangles, which should be included in your diagram. Determine what needs to be solved and create a let statement. Compute that solution. And number 5 is a concluding statement, and make sure you include your units. So let's take a look at example 1 here. Mrs. R is 155 centimeters tall, and she's at the beach, and she had a shadow that was 120 centimeters in length. Determine the angle of elevation. Or you could say the angle of the sun, which is fine, towards the sun. Okay? And just remember, if they don't include rounding, just round to 1 decimal place. So first of all, what do we need to find? We need to find the angle of elevation. So let theta represent the angle of elevation. And remember, guys, the angle of elevation is the angle up above the horizon. So let's now draw a picture. Okay? So pretend this is me, Mrs. R. And here's my stick body. If you'd like to have drawing pictures, here's my stick body, okay? And I have a shadow, okay? And for example, my height, folks, is 155 centimeters. And my shadow, which is going to be my horizontal measurement, my shadow is 120 centimeters. And to find the angle theta, remember it's the angle going up. It's the angle up from the horizon. So in order to do this, ladies and gentlemen, we've got to figure out what two sides have the information. So from that angle of reference, we have our opposite side and we have our adjacent side. So in this case, we're going to use tan. So tan theta equals the opposite side, which is 155, over the adjacent side, which is 120. Remember, when we need to find the angle, we have to use our inverse buttons in our calculator. So the tan inverse of this fraction. Okay, and again, remember the tangent compares the length of the opposite side versus the length of the adjacent side. And when you throw that in your calculator, you should get approximately 52 degrees. So therefore, the angle of elevation is 52 degrees. All right, so that was a simple trig application question, probably familiar to you from maybe grade 10, if not grade 11. Now we're going to deal with a more complex one. But to deal with a more complex one, let's just explore some examples of where we might have to use two triangles. All right, let's take a look here. You don't actually need to write this out unless you want to. I think this will be self-explanatory after you read it, okay? Sometimes you will need to solve problems including more than one triangle. We may have to add or subtract parts of the triangles too. For example, a question is asked in this diagram to calculate the side length AB. We could separate the triangles, then subtract. So for example, AB equals AC subtract BC. Let's take a look and break that down. So if everybody can see that this distance here is not part of a right triangle. So if you're trying to use SOHCAHTOA, you would have to break it down into AC, calculate that side length, then calculate BC and subtract. So again, side length AB equals AC subtract BC. So in that case, you were subtracting two triangles. Let's try to apply that to our last word problem of the day, which is example 2. Example 2, the distance between two office buildings is 73 degrees from the top of the shorter building. So there's one shorter building. The angle of the elevation to the top of the taller building is 31 degrees. So let's start with that. Maybe you do your diagram before you do your let statement. I'm okay with that. So I've got a tall building and a small building, okay? What do I know already? I already know the distance between the two of them is 73 meters. Okay. It also tells me that the angle of elevation from the shorter one up to the top of the other one is 31 degrees. But remember, angle of elevation is based on the horizon going up. So again, that's 31 degrees there. Okay, and this horizontal distance, ladies and gentlemen, is still 73 meters. All right, let's keep reading on. It says at the same location, so up here, okay, the angle of depression to the bottom of the taller tower is 42 degrees. So if I was looking out here at the bottom of the to the bottom of the taller triangle, I would notice that the angle of depression is 42 degrees. Now remember, when you draw these triangles, these are still right triangles, so the top one and the bottom one. Now we need to figure out, how do we calculate this height? Well, again, I'm looking at where my information is, and I've got information in my red triangle, I've got information in my blue triangle. But what I need to do is to get this complete height. So I'm going to say, hey, I can find x from my top triangle, and I can find y from my bottom triangle, and then how do I get the total height? It's going to be x plus y. So my let statement is going to be let x plus y represent the height of the taller building. Okay, so we're going to solve x and y first, and then we're going to combine them. All right, so let's find x. So x is in the red triangle, folks. And what information do we know? Given this angle, of 31 degrees, we have the opposite side and the adjacent side. So we're going to use the tangent. So tan of 31 degrees equals x over 73. Cross multiply, x equals 73 tan of 31 degrees. Plug that in your calculator, guys, and you will get, hopefully, 42.1 meters, approximately. All right, let's try and find y. I'm just going to move this down a bit. So to find y, again, we're using the blue triangle here. What information do we have? We're trying to find the opposite side, but we have information on the adjacent side. So again, we're going to use the tangent ratio. So tan of 42 degrees equals y divided by 73. Cross multiply, y equals 73 times tan of 42 degrees. Plug that in your calculator, folks, and you should get approximately 65.7 meters. Don't forget to answer your question, though. You have to say x plus y equals 42.1 plus 65.7. And that gives us a total of 107.8. Don't forget our concluding statement. So therefore, the taller building reaches 107.8 meters. All right, folks, here concludes lesson 1.4, trig applications. Again, please come see me if you need any help, and have a great day.